For question 7, they say a cylinder container has one end open. Given the shape here, your cylinder is open. Means it has the base, but it don't have the top. It don't have this top area. And the other end is closed, means it has a base here. It has a circular base with radius r. So your symbol using here denoted r. Given the total surface area is 300 pi. First, you have to show your volume of this cylinder in terms of R only. So as we know, volume of cylinder is pi r square h. So what we need to do here is finding the h so that this volume is just in terms of R. After that, only we maximize this volume. So this is the h. So to finding area for cylinder, we use the information given here, area. So we have one circular base. So this area for this circular base will be pi r square plus the area for this side. So all these lateral side here. So as you notice that this length is the perimeter of circle, so it will be 2 pi r. So when you open this cylinder, actually is a rectangle. So this is your 2 pi r, and then the height of the cylinder is h. So for this surface area, it will be 2 pi r h equals to 300 pi. So what we need to find out from this area actually is expressing your h in terms of r. Find out what is your h. So we can factorize your pi. You can notice that. Why we factorize the pi? So that we can simplify it. Then we have 2 r square 2 r h equals to 300. So 2rh equals to 300 minus r square h divided by 2r. So then finally we can proceed to the volume of cylinder. As we know, volume of cylinder formula will be pi r square h. So from here we can substitute the h, which is 300 minus r square over 2r. And you can notice that the r can be simplified. Then we expand until this form. So pi times 300 divided by 2. So 150 pi r. Then pi r times r square will be pi r cubed divided by 2. Shown. So from the part B, we're going to maximize this volume. To maximize the volume, we need to differentiate V respect to R. We need to find the first derivative, and then we find the critical number, then we verify it is maximum. So differentiate it respect to R. So we have 150 pi minus, to differentiate this R, power turun depan 3 pi over 2 power tolak 1 R square. So let it to be 0. simplify until we get the critical number R. Pi can be cancelled out. So R squared equals to 100. So R squared. So remember, when you move your square, you will be having positive, negative of square root. So R will be positive 10, negative 10. So since R is radius, it should be a positive value. So R only accept the value of 10. So this is our critical number, but we haven't verified it. To verify it, we use second derivative test, or you can use first derivative test also can. So for me, I will choose second derivative test, differentiate again, differentiate v respect to r. So differentiate this constant 0. So when we differentiate this, it will be negative 3 pi r. Then we substitute our critical number where r is 10. We get negative 30 pi, which is negative number less than 0. For second derivative test, we show our concavity less than 0 is concave downward. So this is maximum case. Therefore, we get to verify this radius is maximum as value of 10. So look at the questions, what they ask us to find. They say, find the value, the maximum value for volume. So using this radius already maximized, we figure out the volume. So we just substitute back the formula of the volume. So here we have our maximized volume.